Hey everybody, so in this review video I'll be discussing exercise metabolism, oxygen consumption, and how the body responds to increasing exercise intensity. Now, as exercise begins, the body's demand for ATP increases immediately. In response, oxygen consumption increases to support aerobic metabolism. However, oxygen uptake does not instantly meet the body's energy demands. This delay is referred to as an oxygen deficit. During oxygen deficit, aerobic energy systems provide ATP until oxygen delivery and utilization increases enough to meet exercise demands. This is why exercise often feels more difficult during the first few minutes before reaching a steady state. As exercise continues, oxygen uptake eventually reaches a steady state where oxygen delivery closely matches energy requirements. As exercise intensity is increasing, oxygen consumption also continues to increase. Same thing with heart rate, breathing rate, and cardiac output all increase to deliver oxygen to working muscles. However, there is a limit to how much oxygen the body can utilize. This limit is known as a VO2 max. VO2 max represents the maximum amount of oxygen an individual can consume and use during exercise and is considered one of the best indicators of cardiorespiratory fitness. Now, as we just transitioned into some chops here, exercise intensity is increasing further and carbohydrate utilization becomes more dominant. Solely because carbohydrates can produce more ATP more rapidly than fats. This shift in fuel selection is known as the crossover effect, and at higher exercise intensities, lactate production also increases. So rather than being a waste product, lactate serves as an important fuel source. Lactate can be transported to neighboring muscle fibers, the heart, or the liver, where it can be used for energy or converted back into glucose through the Cori cycle. This process is often referred to as the lactate shuttle. Exercise intensity, duration, and training status all influence fuel selection and metabolic process or responses. Now, after we finish chops here in a few seconds, we're going to transition into just a kind of a cool down activity with a little bit less weight. When exercise is decreasing in intensity or stopping, oxygen consumption will remain elevated. This is known as the excess post-exercise oxygen consumption, or EPOC, or EPOC, however you want to call it. And during recovery, oxygen is used to replenish energy stores and help restore homeostasis. Now, understanding these metabolic responses helps explain why athletes train differently depending on the physiological demands of their sport. And just to kind of give you a quick summary here, exercise intensity influences oxygen consumption, fuel selection, and energy system contribution, all of which affect energy performance.